Okay, so we're going to look a little bit deeper into graphing by transformation. And let's take a look at this right here. So I shared with you a link through Desmos. It's not Desmos Classroom. Just this morning you got a weird little Desmos link. If you guys could please find that. I think it says Piecewise 922. Let me know if you have, I mean, you should find it. It's, I think, right there at the top. It's underneath the Zoom session link. But I've got this crazy function right here. And we've been calling this a piecewise defined function, right? Hopefully that's not a big deal. You see this little spot right here? Can you guys turn that on for a second? So I did that on purpose so that that's sitting there. You can see what defined the original function, but we can also turn it off because it makes the water a little bit muddy if you do too much. And we could also turn the actual function off because I don't always want to see it. So let's see if you guys can tell me how to do this. I would like to take this function right here and I would like to move it to the right 4 units. Could somebody tell me how to move this function specifically to the right 4 units? G of x minus 4. Did you succeed in moving the function specifically to the right 4 units? Now, do you notice that it actually did the whole thing? Like it took this little square root, you can't tell, but this was a square root. What's this guy right here? That's an absolute value. That was a horizontal line. It did the whole thing. You see it? It actually moved that thing to the right specifically 4 units. So let's back up a little bit. All right, Jolene, I would like to move it to the left 2 units and down 6. To the left 2 and down 6. So how do I make that thing move to the left 2? Plus 2 inside. And how am I going to make it go down 6 units? A minus 6 where? On the outside. Okay, now the reason I did that is I wanted you guys to be able to see, if you took a look at a coordinate like 5, 6, when you went to the left 2, what did 5 turn into? It turned into 3, didn't it? And the down 6 should have landed at 0, and so you can see the value that you got turned into 3, 0. I could literally plot those points. I don't think I'm too worried about that part. There's a piece in here that I don't know if it landed particularly well that I got to watch for. And so please follow this. And I gave you this strange looking function because in a parabola, I want you to think about what a parabola looks like. Can everybody picture a parabola? What would happen if I took the silly putty that was the parabola and I pulled it this way? What would happen if I pulled it out this way? What would happen to the parabola is it would get wider, right? But what would happen if I took the parabola, silly putty, and I smashed it vertically? Would it also make it look wider? To be honest, yes, it will. Yes, it will. And so I gave you this because there are some things that I want you to notice that you probably understood there, but it gets a little bit weird. What's going to happen if I throw a 2 inside and make it 2x? Anybody know what's going to happen if I put a 2x inside this story? Devin said this way. What happened to the whole graph? It got smushed. Now this is really strange. You should have seen that a minute ago. When I put a plus 6, we subtracted 6 from all the x's, didn't we? When I put a 2 here, it didn't double all the x values. What did it do? It cut them all in half. Because there's a theme that's actually happening here. Anytime you have something on the inside, it does the exact opposite of what it says, and it does it to x itself. So what would happen if I made this a half? And I said, oh, you know what? I want to cut x in half. I'm going to turn this off for a second so I can type it in there. Let's type a 1/2. So this says cut x in half, but if this was some argumentative individual, what's the person going to do? If they're being like opposite day, I'm going to do the opposite of what you said. Instead of cutting you in half, what am I going to do? What's the opposite of cutting it in half? It's going to be doubling. What happened to all the x values? They got doubled. See this point, 5, 6 on the original? It's now 10,6. It doubled all of them. It didn't cut them in half, it doubled them. That's kind of weird. So what would happen if I made it a 1/3? What would it do? It would triple them. It would times them by 3. What would happen if I put a 4 in front? Instead of multiplying it by 4, what's it going to do to all the x values? It's going to divide them by 4, which is going to be, I call it a horizontal contraction, but you could say horizontal shrink. See, it got really, really small. Again, not the stuff that I'm super worried about. Try this on for size. Put a negative in front of your G. Not the original, make a G down below so you can see it. What does putting a negative in front do? It's going to flip it across which axis? The x-axis. Now, what changed? Did the x values change or did the y values change when you were on the outside? The y. Very important. Everything that you ever see on the outside will affect the y value, and everything on the inside is going to affect the x. Put a negative inside now. What happens when you put that negative on the inside? It flipped it on the y-axis. What changed? Did the x values change or did the y values change? The x values changed. Look at it. This says 5, 6. It's still comma 6, but now it's negative 5, comma 6. You see how the x values changed? Now, I'm going to go a little bit further. Here's where we start getting ourselves into a little bit of hot water. So, I'm going to turn this off a little bit. I'm going to go ahead and make it, this will be, I hope, a fairly easy one to understand. I'm going to make it a 1/2 x plus 3. Now, and I wrote this in a funny way, so I want you to follow what happened here. So what is happening? What do you see is happening? Are those inside the parentheses or outside the parentheses? Inside. So I should see absolutely not one thing happen in a vertical direction, but everything should be happening horizontal. So what are the two things that you think are going to happen? What's the half going to do? It's going to double things. It's going to stretch it horizontally twice as big. And then what about that 3? Move it to the left, how far? 3. So let's talk about it. So let's take a point, say 2, 6. And let's talk about what happened to 2, 6. I know you can't see what I'm writing, it's fine. I just am going to keep track of it in my head. So nothing is happening to y, so my y value should remain 6, right? So what do you think my new x value is going to be? You said it was doubled, so 4. And then you said move to the left 3, so you're going to say 1. Okay, so most of you are going to guess this is going to happen at 1, 6. So keep in mind, looking at that spot right there. Hopefully you guys can see it. Did it land at 1, 6? It did not land at 1, 6. It landed at, right here, -2, 6. The question is, what did we do wrong? What did we do wrong? That is not something that is really very easy. In fact, it's in the textbook, but it's written in this really convoluted, very difficult way to understand. So here's what I'm going to show you. Let me do a new share to this right here. And remind me, I think we had g of 1/2 x plus 3. This is dangerous to me to not have this sitting in your notes because it's kind of just weird technology stuff. The theme that I have for you, and I will say this to you like 100 times this year, never, ever, ever let anything be attached directly to x. I can't stress that enough. You see how this 1/2 is attached directly to x? Here's what we're going to do instead. I'm going to rewrite it as this. Now, I'm going to factor 1/2 out. And some of you guys will be like, well, that's weird. That's what? There's no half in this. Yes, there is. You just didn't know it. What needs to sit right here? It's not 3. What is it? It's 6. What is half of 6? 3. So when you looked at that problem and you saw, oh, hey, let's double the x and move it to the left 3, we were wrong. This was wrong. Instead, what we wanted to do is we wanted to double that x, 4, and we wanted to move it to the left 6 units. So if we doubled it, 4, what happens when I move it to the left 6 units? That is exactly the coordinate that we saw. Never let anything be attached to x. So with that in mind, if you were asked to take a look at this, again, this so messes with people's heads. I want you to follow how this works. If someone says, hey, I want to take 3 minus x, what is that going to do to the graph? I need to spend a little bit of time on this concept, make sure you guys have it, and then I'm going to let you guys work. Is anything attached directly to x this time? That answer is, heck yes, there is. It's a negative. And can I allow that to happen? No. So here's what happens. I'm going to take that negative out, and I'm going to put an x right here. Does it still say negative x like the original problem did? Now what? How does this say the same thing as that? I need to put a minus 3. So in order, if you were asked to graph this, question mark, what would the new graph look like? Well, what does the negative inside do? We talked about this already this morning once. What does the negative inside do? It flips it across the y-axis. So it flips across the y-axis. So it's going to go this way. So it's going to take the coordinate 2, 6. And the first thing it's going to do is it's going to flip it across the y-axis and make it negative 2, 6. By the way, this is how I want you to do your work today. So the first thing I notice is right here. It's going to flip it across the axis. Got it? Then what's going to happen? What does this minus 3 do? It's going to move it to the right 3 units. Which one? The x or the y if you move to the right? The x. So 2, 6 is ironically going to turn into 1, 6. Let's see if in fact that is what happens when we do this. So keep in mind we were changing one value. 3 minus x. Did 2, 6, this dude right here, did it turn into 1, 6 right there? Isn't that kind of weird? That is not at all what I understood when I was in high school. We did not have this technology. I literally could not answer this question. I couldn't do it. I did not know how to answer that question back in the day. So let's go ahead and let's look at one more little set, and then I'm going to have you guys get going. How about if we took a look at G of, let's try to give you the whole kitchen sink this time. And I'm only going with the coordinate 2, 6 because it's just a simple little coordinate and I don't really care too much about it. If we did 2, 6, we could have done any other coordinate. So let's just see what happens. Now, one thing that I would like to also keep in your head is when you say this PEMDAS thing, when it comes to graphing by transformation, these two ideas are first. These ideas are second. That's a pretty important little thing. Now, first little rule is anything right now attached directly to x? Is there anything? The 2 is. So how should I rewrite this so that there is no longer anything attached directly to that x? I should take out the 2 and make it a parentheses x. Well, x plus 4. Yeah, there we go. There we go. There we're getting it. Now, let's talk about it. Who is the 3 going to attack? Is that going to attack X or Y? Is it inside or outside? Outside. So that's going to affect, oh, I just screwed that up. Doggone it. You just told me the right answer and I just wrote it wrong. Let's fix that. So it's going to do something to 6. Who else is going to attack the Y value specifically? What other one of these numbers would attack the Y value? The 5. So let's do that. I honestly love to do it this way. So if this was A, then A prime, do we do the multiply by 3 or the add 5 first? Which one comes first? The multiply. So I'm going to get negative 18, then I'm going to add 5, and I got negative 13. So let's go inside. I'm going to do this in pink. These guys are going to affect that. So which one happens first, the 2 or the 4? The 2 does. The multiply happens first, the 4 happens last, but the pink guys are jerks. You got to understand that. Those are jerks. Those are always going to do the opposite. This says multiply by 2, so what am I going to do? I'm going to divide by, so what did 2 turn into? 1. And then what did 1 turn into? Negative 3. You see how it kept getting messed up royal. So the coordinate 2, 6 becomes the coordinate negative 3, negative 13. Let's see how we did. So my function was, I put a negative 3. So let's go ahead and put this here. So first off, can somebody tell me what happens? Now I have a negative 3x, right? So what is the negative going to do? Tell me one step at a time. What's the negative going to do? It's going to flip it across which axis? The x-axis. It's going to make it go upside down. Boom. What's the 3 that I put in here going to do? It's going to vertically stretch it. Boom. Make it taller. Cool? What is the plus 5 at the end going to do? It's going to take the entire thing and it's going to do what to it? Move it up 5 units. You can't see very much of it because the graph is now kind of obnoxiously tall, isn't it? Because that 3 did that. Now let's go inside. And I like to put a parenthesis around that x because we don't want anything to be attached directly to it, right? So what does the 2 right here going to do? Ooh, this is weird. What is the 2 going to do? It's going to shrink it horizontally. It's going to cut it in half. So it's nice and tall, and now it's even skinnier. And what's the last little piece? Inside we had a plus 4, which is going to do what? Moved it 4 units to the left. Now that's a big chunk of information, but see this 2, 4 right here? That's going to be this dude right here. And I think we predicted that that point would be down here at negative 3. I can't get it where I wanted it. I feel like I may have messed up. I got the negative 13 right, but this is claiming that the value is at negative 1.5. Did we mess up? Did I write down the original problem wrong? Cut it in half, it became 1. Moved it to the left 3. That's right. I must be looking at the wrong point. Oh, I am looking at the wrong point. It's this one right here. It was this guy right here. Anyway, so that's kind of our story that I would like you to do. So what happens for today is I would like you to go to the activity that we had done. And what I've also added to that is this graphing by transformation worksheet that is sitting right here. So the one that I'm showing you right here, this is actually not going to be very hard. This is the graph I'm calling F. You see it? What do I want you to do to the graph? Move it to the left 4 and down 1. This one, you're going to go ahead and take all the x values, you're going to cut them in half, and then you're going to move them up 1. You're just going to, and all I would do to do these graphs is I would just cherry pick a couple of easy values. Like on this one, I would probably take these points right here. If I had those points and I moved those points, could I come up with a new shape that's related to it? But I also in Classroom, I shared you another Desmos activity. And the reason I did that is all of these crazy things are sitting in that Desmos activity. So it'll help you a little bit. So you've got 2 Desmos things to work on for the rest of the period. We've got roughly an hour to do so, just a tiny bit underneath. Start on the activity from yesterday. Please do school bus, sit side by side, talk to each other, argue, discuss, make sure that you understand. Today is the end of 1.6, graphing by transformation. So hopefully that will be helpful.